Wow. Well, good evening, everybody. And thank you very much for having me. My mum is in the audience, so I have to get my P's and Q's done. So I'm here to talk about what I do and how I see the world. And so I'm a scientist, and actually I'm a paleoclimatologist. And what that means is that I look at how the climate has changed in the past to try and help predict or understand how it might change in the future. And this is my laboratory. So this is my stage where I work. I work in some of the coldest, driest, and windiest, that's what the sound is, places on our planet, so particularly around the polar regions, Antarctica. And on a good day, I'm incredibly privileged to be there because some of the scenery is absolutely spectacular. And it's a real privilege to actually be in parts of the world, these amazing, fragile ecosystems, and to actually witness some of the climate change and see some of the incredibly charismatic wildlife. But it's fair to say that actually spending huge amounts of my time living and working and in a tent can be quite difficult. So the projects that we look at, or we spend maybe weeks or sometimes even months living in a tent. And so that means everything that you need for that entire time that you're there, it's incredibly remote, you take with you. So if you need water, you have to dig it and melt it. The food comes in rehydrated packets and tastes awful. Anything that you take down there with you, your equipment, if it fails, you have to find a way of fixing it yourself. And if you want to have a shower, well, you're completely out of luck. But the reason that I travel to see these amazing parts of the planet is because I really care about the planet and how the climate is going to change. And so I'm sure that most of you, or it's unavoidable, these headlines for how the climate has changed. And particularly in the last 12 months, we've had these headlines because 2023 was the warmest year on record. And not just in the atmosphere, but also in the oceans. We've had ocean heat waves. And we've also had an increase in what we're terming extreme climate events. So these are things from flash flooding, droughts, forest fires. And these are all having a really catastrophic impact on humans everywhere. So just to be clear, because sadly, my clicker isn't working. Just to be clear, there is a really clear consensus, and has been for some time among the scientific community, of what's driving this increase, particularly to this climate change. And that is because we have a growing dependence on burning of fossil fuels. And put very simply, that releases huge amounts of carbon dioxide and methane, the so-called greenhouse gases, into the atmosphere. Now, these greenhouse gases are actually very important to the climate system. They play a really huge role in maintaining and modulating our climate. And the fact that they're even there in the first place means that we're able to trap heat, and that is why our planet is habitable. But what we're doing is we're increasing the amount of carbon dioxide in the atmosphere at a pretty alarming rate. And what that means is that in the future, if we continue to emit huge amounts of greenhouse gases, the climate is going to continue to change. And all predictions are pointing to the fact that the temperatures are going to get much, much warmer. So as a scientific community, we've come together and we've generated a number of scenarios or predictions for how the future is going to change. And these are based on a number of different factors, so taking into account changes in technology, social, political impacts, as well as the climate system. And even in our sort of so-called middle-of-the-road scenarios, so shown in the yellow, this is where we gradually start to move towards living in a more sustainable way. And towards the middle part of the century, we start to gradually reduce our dependency on fossil fuels. But even in this sort of best-case scenario, by 2100, temperatures are going to be as much as 2.7 degrees warmer. And as you can see, some of the other scenarios are quite a lot scarier. And it's not necessarily just the temperature that we're concerned about. And one of the things about the climate system is it's hugely complex. So it's not just about the globe getting warmer, it's about different areas of our planet reacting very differently. So some areas we might see an increase in droughts, others it could be an increase in precipitation, we could get flooding. Other places it might be just a change in seasonality, which means that June is incredibly cold when it really shouldn't be. But importantly, some of these things are also just the warming of the atmosphere in the oceans means that our cryosphere, the places in our planet that are covered in ice, are melting. And that obviously is going to have a very big impact by driving sea levels, which is going to affect millions of people and infrastructure. And this is where I come in, and the ice. So in the polar regions and in some of our high mountain regions, snow falls every year, and it doesn't melt away, it accumulates. And it means that it can build up layer upon layer. And for Antarctica, we can build an ice sheet that's many kilometers thick in its center. And what I do is I travel to these remote places, and I drill down through this ice sheet. So the little video that I'm trying to show you here is actually your view of coming out of an ice sheet. So as we start to drill down. And I drill in sections. So this is the view down through that borehole. So we drill in sections, pulling up cylinders of ice, and when we put that information together, we can basically go back in time. It's a time machine. And this has taken me to some absolutely amazing places. So I've been fortunate to go to both Antarctica and Greenland, leading expeditions. And I've also been working particularly on the areas that are really changing very rapidly. So these are parts of the planet that are rapidly warming, and so the ice that they contain is actually at risk of melting away. So I'm trying to get there before that happens. And places that I've been to include Bouvet Island, and this is the world's most remote island. So it's an uninhabited island. It's only 5 kilometers long. It's an active volcano, and it's in the middle of the South Atlantic, only accessible by helicopter and ship. And for me, this is one of the most beautiful places I've ever been, but also one of the most truly terrifying. But I go to these places because the information that the ice contains is so valuable in really helping us to understand this really complex planet that we live on. So what I'm showing you here is, although the places I visit may seem very remote, actually our planet is all connected. Through the atmosphere, through the winds, and through the oceans, everything is mixed. So the atmosphere can transport particles, aerosols, from distant continents, but also from the open ocean. So for example, we can lift up sea salts from the ocean. And in the top here, this is a marine diatom. This is just an algae from the surface of the ocean. It's uplifted by strong winds, transported hundreds of kilometers, where it's deposited on the ice, and we can go back and find that information. Some of the other things we look at is volcanic ash, tephra. So this gives us an indication and a record of past volcanic activity. So there's a huge amount of information we can capture from this ice. But sadly, we're also picking up very strong evidence of human activity. So we're picking up the pesticides, the heavy metals, pollutants, and also the ice actually has got an indelible marker of radioactive activity, so from the nuclear bomb testings in the 1950s and 60s. And then the other particle just down here, this is a fly ash particle. Now this quite strange-looking structure is uniquely formed by the high-temperature combustion of coal in power stations. And this particular particle was found in an ice layer from the Antarctic Peninsula, and the layer was from 1936. So we know that that particle traveled over 8,000 kilometers from southern Australia, because that's when the start of the Industrial Revolution for Australia began. Now that strange sound in the background isn't just because I've messed up my microphone. This is why I have this ice here. And what you're listening to is actually the bubbles. So all of those amazing things I've just spoken about, this is a piece of Antarctic ice. So just looking at it, you probably don't believe me that all of those things are in there. And in terms of the whole radioactive thing, it's no more radioactive than a banana, so we're fine. But what you can see, so everything I've been talking about so far is microscopic, but what you can see is these bubbles, and in the image there. And so the reason why I want to point this out and why it's so important, and that fizz and crackle that you can hear, is air that's escaping. So as the snow falls in Antarctica, it traps with it a little time capsule, a little snippet of the atmosphere, which becomes buried into these bubbles. And actually, it's really fizzing away in my hands. And it's really amazing. I'm going to put it down, because otherwise I'm going to drip all over myself. But just, I really wanted to bring with a little piece of Antarctica so you can really see what I'm working on. And it's also important to see that this is the data that we extract from here, from just taking that air out of a bubble. We're not doing anything with it. It really is. So the air that just came out and is still coming out and fizzing now, this is actually from a time before the Industrial Revolution, so a time before we started emitting huge amounts of carbon dioxide and methane into the atmosphere. So that air is the cleanest air you're ever going to breathe. So the ice that I brought with me is actually relatively young in ice core terms, so just a few hundred years, because I wanted to get something just at the start of the Industrial Revolution. But we can actually go back many thousands of years. And our longest records take us back 800,000 years. Now, I'm aware that this seems like a really strange amount of time, but just for reference, modern humans, Homo sapiens, we've only really dominated the planet for the last 200,000 to 300,000 years. So this is a very long record. And what this shows is that over that 800,000 year cycles, we've seen the Earth very naturally changes from these warm periods, such as we're in today, they're called interglacials, to very cold periods, the glacials. And carbon dioxide and temperature follow each other really nicely through all of this time. But what's really striking is when you start looking at the end of the plot there, that's what happened during the 20th century, that big increase in carbon dioxide. And actually it gets a whole lot worse. If I start to put on the modern day values on here, so this is what we're measuring now in the measurements in Hawaii, 425 parts per million. So I want to leave really with this very strong message that the amount of carbon dioxide that we're emitting into the atmosphere today as a result of our dependency on burning of fossil fuels means that the concentration of carbon dioxide in our atmosphere that we're breathing in now is higher than it has ever been in the past 800,000 years. Now, this is a bit of a scary message to end on. So although it's, I think, still important that as a scientist it's my job to talk about this and say that this really is real and it's happening, but I don't want climate fatigue to set in, so it doesn't mean that all hope is lost. We are a huge population globally, and if we all just make very small changes to our lifestyles to be a little bit more sustainable, thinking about what we're eating, reducing our red meat, thinking about how much waste, if we make those small changes collectively, we will actually make a difference. And for my final slide, I'm going to finish. So this was my most recent trip to Antarctica in February. I got back from Halley Research Station. So I had a project drilling on the Brunt Ice Shelf. And the reason I'm finishing here is because Halley Station was where they made the discovery of the ozone hole. So this was back in 1985. They realized that the ozone was being attacked by man-made chemicals, which was actually causing the ozone to be depleted and forming a hole over Antarctica. And the ozone hole, well, the ozone forms this really protective layer protecting us from harmful UV rays. But the scientists came together, there was consensus, and that led to something called the Montreal Protocol. And this was where arguably the most successful multilateral environmental protocol that there has ever been. Governments came together, they pledged to reduce and eventually ban up to 100 of these species that were actually harming the ozone. And as a result, the ozone hole is now recovering. So I just want to finish on this note that we really shouldn't give up, and we really should keep putting pressure on our governments and actually following through with some of the actions that need to be done. Because if they could do that back in 1987 with CFCs, then I really do feel like we can do that now to reduce our dependency on fossil fuels. Thank you.